Hello and welcome back. Well, many of you may have seen my 1931 South Bend lathe restoration. If you haven't seen it, be sure and check it out. I'm really pleased with the way it came out. But the one thing I didn't like about it was the dials. The cross slide and the compound dials were small and incredibly hard to read. Some of that was rust, but the original dials just weren't very good. So I made larger dials. I extended this lead screw here so that the cross slide didn't hit it, so I could put a larger dial on it, and made a larger dial on the compound too. But I'm really pleased with the way they came out, so well, let's get on with it. I'll show you how I did it. Okay, these dials need to be replaced. I can't hardly read them. But here's the problem. The cross slide comes across the dial, so I can't make them any bigger. So I need to extend all this. How far, I don't know, but I'm guessing at least the width of those dials. So I think I'm going to go another inch. I don't want to make it stick out there too far. It'd be something to run into. But that way I can make that dial 2 inches in diameter if I wanted to, I think. I had a hard time getting that off the first time, but it came off. Used some penetrating oil, and there's where that little piece of rod went right there to key the handle to it. The dial slipped on there. Had a little set screw. But what I need to do is extend that rod another, let's go with 2 inches. So I'm going to have to figure out how to screw a rod onto that and key it to that shaft. And then I need to make a new one of these. Should be pretty easy, I think. I don't know what that bore is. I may not have a ream that size. I don't know. I'll have to look into that. Okay, that's 5/8, a little under actually. Okay, I need to bore a hole in there. That depth, or that diameter right there, which is 7/16, a little over 7/16, and I need to bore at that depth right there. And it needs to be 5/8 of an inch deep. Okay, there's 5/8 deep. Now I'm going to drill for this little threaded area right there, which is 5/16 fine thread, 24 threads per inch. The depth on this is not critical, it just needs to be about double what I'm going to say, about a little over ½ inch. Now I'm going to ream that larger bore. The shaft is a little bit over 7/16, so I'm going to go a 1/over reamer. I'll just slow that down. Now I got a thread the smaller hole. It's got a spiral tap here. We're going to try that. I've used them before. They work pretty good. This one here is one somebody gave me. I don't know. It may not be sharp enough. Let's see how it works. Uh-oh. Alright, slipped in the chuck a little bit. Bottom the tap out. Okay, let's give this a try. I'm a little worried about those threads. They're boogered up a little bit. Okay, I got that pretty much all the way on. Now I scribed a line right there. That's where that little key is. And a 1/2 inch in, I need to put a center punch and put a tiny little set screw that'll go into that little recess. Keyway, if you want to call it that. I wonder why that's so tight. I wonder if it's the threads or... I think this is oversized a little bit. I may sand that down a little bit before I screw this back on. I don't have a neck size reamer. That set screw will fall right into that, I hope. Looks like it will. Seems like a good fit. Take that set screw out and make sure I see that little... There it is right there. There we go, that's all one shaft. There's a very slight gap there, but I think it'll be fine. Stick it in the lathe and see how close we get. Got a little bit of a wobble to it, and I could just turn that off of there. Okay, what I really need to do is duplicate that on here. So I need to turn down to 7/16 here and 5/16 there. That's it. Good deal. Okay, well, that's fairly straight. It's not exactly dead straight there, but this is the same as this now. We're real close. There we go. We got an extended lead screw now. And if I wanted to make it all original, I'd take that out, unscrew that, and I'd have the original shaft there. Yep. Works good. Okay, I need to make this piece right here. But I need to make it, well, not really that long, but I'm going to start out that long. Trim it down to whatever size I need. First thing I want to do is duplicate this portion. I'll worry about this side later, but I got to turn this down to the outside diameter of that thread right there. 1 inch, 54 thousandths. Boy, that's an odd size. I'd say it is a little bigger than that. It's probably 1 inch and a 1/16. 1 inch, 62 thousandths. That's what I'll make it. 88 minus 62 divided in half is 13 thousandths. Perfect. Now I'm going to clean up this mess and then cut those threads. Alright. I can make the dial whatever width I want. I want to aim for about 3/4 inch, so I think that's, yeah, it's 3/4 inch right there. And I want to cut that off now and I'll face it just so I don't have as much to drill. It's always hard to drill something that long. It looks about right. I can always trim more off later. Well, let's drill through this thing. Put my larger chuck on. It's a little bit, it chatters worse because it's got more overhang, but it's a little bit more true, quite a bit more true. Well, this is 1.5 inch, and I'm going to make my dial 1.5 inch, and I'll put a sleeve over that and then the dial, I think. But this will be this will be what I put a mark on as a reference mark for the dial. But right here the cross slide comes into this area, so I've got to turn this down except for that much. And that'll be the reference for the dial. It'll hold the reference mark. Okay, I'm having a really hard time with chatter. Obviously the overhang there is the problem, but I don't have enough to hang on to here. I've got a live center here. I've never had much luck with live centers, but it'll probably help support that. Maybe it'll make it so I can get a smooth finish on that. Ultimately, I'll get a smooth finish, just by taking small amounts, but I'd like to take another 1/8 inch off of there and not do it in a couple thousandths at a time. So we'll give this live center a try. Well, that helped it a little bit. Okay, that's good enough. Okay, I got that little pin right there. It's kind of like a key. That's a round keyway. I'm going to mill a slot for that to engage with. And then I'm going to mill the keyway right here. For a sleeve, and I'll explain that further in a minute. Boy, these little mills are easy to break. I think that'll work. Now, that sleeve will slip off and on. That will be pinned to the shaft, and there'll be a nylock nut on there to control the backlash. Then the dial will be independent. I could have made it a little longer. That's a good 1.5 inch more travel than it had. Anyway, all we got to do is put a witness mark there, reference mark, whatever you want to call it, and make our dial. Okay, let's put this dial making jig on. You remember how it goes. It's really pretty simple. It's just a 100-tooth saw blade on a simple mandrel. Then this goes in there. It needs to be good and tight. You don't want that saw blade slipping, although there's no load on it. Okay, this and this right here is a clicker. Position that and then clamp it. It's a real high-tech jig, you know. Anyway, take it out of, disengage the spindle, and that's your describing the marks on your dial. Okay, what I found out is 10 to 15 thousandths in depth is what we want. So I'm going to touch the dial over here, and I'm going to add 13 thousandths, see what that does. It's a pretty big cut. I think that looked pretty good. I'll go a little bit deeper. Okay, now to the next 10. Got it, where I started. Now I got to reset my carriage stop and make the fives. Okay, I'm on my first 5. Here goes. There's a 5. Now I want to set it up for 1s. Appropriate length is just like match it up to a ruler, you know. Just use your best judgment. Drill it and stamp numbers on it. I made this jig for another dial size. It should work on this just fine. It's got a mark right here. You line up with the 10 mark. Need good lighting. Line it up with the 10 mark there. And then put your number on the other side. Not too bad. weed eater line. I may have to shorten that weed eater line or put a shorter set screw in. Okay, I got this sleeve on there. Then the dial. I made a little washer, not absolutely necessary, but knob goes on there, and this little tiny pin. Pretty good. Well, it's not the best dial I've ever made, but it's way better than what it was. Didn't lose any travel. Yeah, I just cleaned the dial up with acetone, degreased it. Gonna make these numbers stand out with shoe polish. That's better than what it was. Okay, let's replace the dial on the compound. This dial on the cross slide was 1.5 inches. I'm going to make the compound 1.25 inches just to kind of keep things in proportion. This dial, I'm going to basically do it the same, and I'm going to make this piece, but I'm not going to make an extension. And the reason I'm going to do that is because I want to, this is going to be the dial. Believe it or not, there's a dial on there. But I want this to be a little bit wider, without having to extend this. So I'm going to make this thinner. I'm going to make a piece that screws into there with a real narrow flange that has the reference mark on it, or wetness mark. So basically got to make this piece right here with a round flange on it, the diameter of the dial. Basically what I got to do is make this over again. So I got to turn it down to this outside diameter right here. I think I may do that with a cutoff and grooving tool. This is a GTN insert, GTN 3mm wide. I did a video on this cutoff tool. I've got a better cutoff tool, but this is really great for grooving, and it cuts laterally, which is really nice. I'll show you what I mean. Let me make sure my feed's the right direction. Got a mark on here. I gotta. There we go, right there. That's my zero, right? So it cuts laterally. I'm cutting out a little groove for the thread relief, the back out of my thread. 16 threads per inch. And one more pass will get it. Okay, let's see if those threads fit my compound. Hopefully they will. Perfect. Okay, I'm using the cutoff tool I designed here with auto feed and a lot higher speed than most people do cutoff work. Speed rate might be too slow. I don't know. No, it's not right. This cutoff tool works really good. Shouldn't brag too much about it, it'll probably malfunction now. So you gotta keep plenty of oil on it. Cutoff is kind of messy. That's a smooth cut. By making that thin, I can maximize the depth of my dial there, which is still kind of narrow, but it's still wider than if I used the original. So my dial width has to be 0.55. 550 thousandths. Okay, this is a sleeve to go underneath the dial. Slot that hole so that I can slip that sleeve over there without, so I can get it apart in the future. Perfect. Now I can set my handle wherever I want to control the backlash, and the dial will still be free to move and unaffected by the any adjustment I make, I hope. Good deal. On back to the dial. That's the dial that'll fit over that sleeve we just made. I'm going to cut a groove the depth of the dial, or the final width, and then I'm just cutting a chamfer on the back of the dial, decorative chamfer. Because of the width of this dial, it's a little bit narrower. I got to start out with my lines a little shorter, like a 1/4 inch for the long line. Got to have room for my numbers. I got to set the depth of my scribe, which I went a little shallow on the last one. I'm going to go a little deeper on this one. Okay, that's up against the dial. And I want to go 1/13 thousandths last time, I believe. May have moved on me too. I'm going to go 17 thousandths. Okay, there it is. Must be at least 100 ones. I'm kidding, of course there is. Seemed like there's a whole lot of them. And 400 yet. That's what we just made in the lathe. Inside of this dial diameter's slightly smaller. Well, I erased the numbers. You see that? Try this again. 0, 0. One. I got it right that time. You know what? I'm going to put shoe polish on them before I put it on. Yeah, it looks better. It doesn't stay in the numbers real good, but I'd say the numbers are more like a V groove, whereas the scribe lines are like square, and they hold it a little better. Okay, let's put this thing together. Put our little keyed sleeve on there. Goes on there kind of firm. There we go. It's got a little burr on there or something. Anyway, that sleeve takes the thrust of the backlash rather than the dial. And the dial goes on there. And then the handle, and it's not going to line up right with those holes. I wish it would, but that's the backlash that handle does. which is just about perfect when you push it in there firmly. I don't think that's going anywhere. And this little set screw's got the nylon under it, which sets the resistance. So if you want to reset to 0, you can hold the handle and turn it to 0. And then, now that sleeve in there, if I didn't have that sleeve in there, when you turn that, if there wasn't enough resistance on that nylon, the dial would move. So that's the reason for that sleeve. But I think they turned out good. I wish that I'd scribed these a little darker, but they're still way better than the original. Here's the original. Let's take a look at the bottom one. Here's how the original would sit. And of course it's extended out to clear that, so I get full movement on my cross slide. Here's the other dial. I don't think that dial was ever legible, but it certainly isn't now. Got a lot of corrosion. I can see little tiny increments on there. I look real close, but most of them are gone. That's a big improvement. It'll make this lathe very usable. Well, that's about it, and thanks for joining me, and be sure and subscribe.